Today we're solving sliding window maximum, a classic interview problem that separates beginners from advanced candidates. You're given an integer array nums and a window size k. The window slides from left to right one step at a time, and at each position, you need to output the maximum value inside the window. For example, if nums is the array shown on screen and k equals 3, the output is 3, 3, 5, 5, 6, and 7. The brute force approach checks all k elements every time the window moves. That gives you O of n times k time complexity, which is too slow when n or k is large. The efficient solution uses a monotonic deque. The idea is simple. We only keep elements that could possibly become the maximum in the current or future windows. Everything else gets discarded. Here's how it works. We maintain a double-ended queue that always keeps elements in decreasing order. The front of the queue is always the maximum of the current window. When a new element comes in, if it's larger than elements at the back, those elements can never be the maximum again, so we remove them. We keep doing this until the queue is decreasing again. Let's walk through the example. We take 1. The queue contains just 1. Next, we take 3. 3 is larger than 1, so 1 gets removed. Then we take -1. It's smaller than 3, so we add it to the back. The window is now formed, and the front of the queue is 3, which is our first maximum. The window moves right, and we read -3. It's smaller than -1, so we add it directly. The maximum is still 3. Next, we read 5. 5 is larger than everything before it, so -3, -1, and 3 all get removed. This means once 5 appears, all previous values become irrelevant. The queue now contains only 5. The current maximum is 5. We continue sliding. We take 3, which is smaller than 5, so we add it to the back. The maximum remains 5. Then we take 6. 6 is larger than both 3 and 5, so they both get removed. The queue now contains only 6. Finally, we take 7, which removes 6, and the queue contains only 7. This is the Python implementation. If you're interested, pause and study it yourself. Notice we store indices in the deque, not values. Why? Because we need to check if an index is still within the window. Each element enters and leaves the deque at most once, so time complexity is O of n. The deque holds at most k elements, giving us O of k space complexity.